Hello, math humans. We're going to do 10.7b today. We're going to be talking about polar equations. So our objectives are that we're going to convert regular equations to polar equations and then vice versa. So for you remember, x is going to equal r cosine theta, y is r sine theta, x squared plus y squared is r squared. In case I haven't mentioned, remember this is the equation of a circle located at the origin or the pole, okay? And then tangent theta is sine divided by cosine, or y divided by x. So we're just going to jump right in with our examples today, and I'm going to convert r is equal to 4 secant theta to a rectangular equation. Get my water bottle out of the way. So when I start this work, I'm going to write r is equal to 4 secant theta. And because secant's not sine or cosine, I'm going to divide both sides of the equation by the secant of theta. So when I do that, I'm going to get r divided by the secant of theta is equal to 4. Secant is the reciprocal of cosine, so you're going to get r cosine theta equals 4. And then this is almost where we need to be. R cosine theta is x is equal to 4, and then this is a vertical line. So that's kind of cool. So it's a way of getting vertical lines in your calculator. You can just graph them in polar coordinates. Who knew? For the second example, I want to convert r is equal to 4 cosine theta to a rectangular equation. So in this one, it's a little bit different. R is going to equal 4 cosine theta. Since it's already in terms of cosine, I'm going to multiply both sides of the equation by r. When I do that, I'm going to get r squared is equal to 4r cosine theta. Well, now r cosine theta is x, so I'm going to get 4x is equal to r squared. R squared is x squared plus y squared. Okay, now we get to do some completing the square, so I'm going to move things around a little bit. So I have x squared minus 4x, I'm going to leave some space, plus y squared is equal to 0. Just looking at my math, making sure I haven't done silly mistakes. We're going to do completing the square because we love completing the square. Half of 4 is 2, squared is 4, so I'm going to do plus 4 here and plus 4 here. Now I'm going to factor x minus 2 quantity squared plus y squared is equal to 4. And now I'm done. This is a circle. Okay. Notice that it has a center of 2, 0, and its radius is the square root of r squared, which is going to be 2. So that's kind of cool. Okay. Next example, example number 3, I'm going to convert r is equal to a negative 2 cosecant theta to rectangular form. This one's very similar to the problem that we did just a few minutes ago. The difference is now I'm going to divide by cosecant. So I'm going to write r is equal to a negative 2 cosecant theta. By dividing by cosecant, I'm going to bring sine or cosine to the numerator. So when I do that, I'm going to get r over cosecant theta is equal to a negative 2. Cosecant is the reciprocal of sine, so I'm going to get r sine theta is equal to a negative 2. R sine theta is y, so y equals a negative 2. So now I've gotten a horizontal line. Okay. All right. Example number 4. Cruising right along. I want to convert r is equal to 4 cosine theta minus 4 sine theta to rectangular form. So in this one, if you'll notice, I have both a cosine and a sine, so I'm going to end up completing the square twice. Okay? So 4 cosine theta is missing an r, so is this guy. So again, I'm going to multiply both sides of the equation by r. So I get r squared is equal to 4r cosine theta minus 4r sine theta. R squared is x squared plus y squared. R cosine theta is 4x. R sine theta, this guy right here, is y. So I get, there's that. I forgot my 4. Now I'm going to put all of my variables together. X squared minus 4x, leave some space, plus y squared plus 4y equals 0. Now I'm going to do completing the square. Half of 4 is 2 squared is plus 4. And then half of 4 squared, so plus 4 and plus another 4. This is x minus 2 quantity squared plus y plus 2 quantity squared is equal to 8. So again, on this one I have a circle. Okay, my center is going to be 2, negative 2, and my radius is going to be 2 radical 2 because it's the square root of 8. Now, you don't have to give this information unless the problem asks for it. I just think it's interesting to point out that the equation that we started with turned out to be a circle that we already know and understand. All right, example number 5. We have 2 more examples. So for example 5, I want to convert, so we're going to go the opposite direction, x minus 1 squared plus y squared is equal to 1 to polar equation. Bad grammar, sorry. To a polar equation. Ooh, that's better. So I'm going to start by expanding. So I'm going to get x squared minus 2x plus 1 plus y squared is equal to 1. Well, if you'll notice, these 2 ones cancel right off the bat. Okay. I know that x squared plus y squared, so x squared plus y squared, I'm going to just kind of write it like this, is equal to 0. X squared plus y squared is r squared, and then y is a minus 2r, that's supposed to be an x, 2r cosine theta, okay, is equal to 0. It's still not quite in the right form, so I'm going to factor out an r, and I get r minus 2 cosine theta is equal to 0. I'm going to divide both sides by r, so I get r minus 2 cosine theta equals 0, so r is going to equal 2 cosine theta. Okay, remember that 0 divided by r is 0, so then it's polite. And now I have my cool polar equation. All right, I have one last example for us. Ooh, got to sneeze. So for example number 6, I want to convert, maybe not, 3x plus 4y equals 2 to a polar equation. The grammar's better that time. So I'm going to start by rewriting the x and the y. So x is going to be 3r cosine theta plus 4r sine theta, and it's going to equal 2. Now I'm going to factor out the r, and I'm going to get 3 cosine theta plus 4 sine theta equals 2. And then now I'm going to solve for r because that's what I need to have my regular polar equation. So I'm going to get 2 divided by 3 cosine theta plus 4 sine theta. And just to show you that that's a valid polar equation, let's put it in our grapher. So I'm going to go to my y equals, and I'm going to enter 2 divided by parentheses 3 cosine theta. By the way, your calculator does have to be in radians, just like it does with all other trig functions, otherwise it doesn't work. Theta, close. Notice that my variable is theta when I am in polar coordinates. And I'm going to do zoom 7. And let's see what happens. Oh, look, it's a straight line. Well, let's go back and look at our original equation. Notice that our original equation is a straight line. When I put it in polar coordinates, it's also a straight line. It just drew the bottom half before it drew the top half. So that's kind of cool. That's it for today. Happy mathing!